Hey guys, a very good evening everyone and welcome to today's session. So we have been discussing about the capital market analysis for the past few days and today again we'll be discussing about how to perform the exploratory data analysis, also called as your EDA, in your particular analytics. So we'll be talking about EDA and pre-processing. How do we do it? What is the use of doing it? And we will also be doing the hands-on on the Jupyter notebook. Okay, so let us proceed. When we talk about EDA is an approach to analyze the data using visual techniques. It is used to discover the trends, patterns, or to check your assumptions with the help of statistical summary and graphical representation. In other words, if I were to say EDA or your exploratory data analysis refers to the critical process of performing initial investigations on data so as to discover patterns, to spot anomalies, to test the hypothesis, and to check your assumptions with the help of summary statistics and graphical representations. What happens over here is EDA starts by asking some basic questions on the data sets to make an initial assessment of data structure and quality to facilitate a plan of attack. Now, these questions may include, is there an existing unique record ID? Are the fields populated with numbers, dates, or alphanumeric characters? What is the distribution of your numeric values? How many values exist for categorical fields? How many fields have been left blank? How are multiple data sets related? So based on this, you can perform your EDA. This is what the questions are generally being asked when you perform your EDA. Another thing is, when we talk about exploratory data analysis, it consists of two types of analysis. One is your statistical analysis and one is your graphical analysis. Not only we perform some statistical analysis on our data set, whatever inferences we are getting, we try to visualize them as well. Talking about the statistical analysis, in your EDA, we perform first, second, third, and fourth moments of business decisions. The first moment, business decision, is also called as your measures of central tendency. And we do our mean, median, and mode. Mean is nothing but the average. That is, we find the average. But the drawback over here is that our mean or the average gets influenced by the outlier. That is why we resort to median. Median is nothing but the middlemost value. And more, when you have a categorical data, we use it. And this is nothing but your most repeated value. Few other things. That is all about your first moment business decision. Then you are having second moment business decision. In this, we find out the variance, standard deviation, and range. When you find out the variance, the drawback over here is the units gets squared. To get the original unit back, we resort to standard deviation. And range is nothing but your maxima minus minima. Right? Third thing, third movement business decision, also called as a measures of asymmetry. Here we are trying to find out the skewness, whether our data is positively skewed, is negatively skewed, or you are having a normal distribution. Measures of asymmetry, skewness. You also have in the fourth movement measure of peakedness or your kurtosis. How peaked, if we are having a sharp peak, if we are having a wide peak, we measure. This denotes positiveness, this denotes negativeness. These four business moments you need to do when you are performing your EV. But besides doing your statistical analysis, you need to visualize your inferences as well. And that is what we do in our graphical analysis. We have univariate analysis. When one variable is used to summarize the variables, that is bar plot, histogram, or box plot. Bivariate means 2. Uni means 1. Bivariate analysis on the two variables to determine relationship between them, like a scatter plot. And if we are having multivariate, means multiple variables, to determine interrelation between them, use a pair plot, heat map, so on and so forth. That is a multivariate analysis. Another thing that comes up in our EDA is pre-processing. And in pre-processing, we have text pre-processing. Text pre-processing is a method to clean the textual data and make it ready to feed data to the model. Text data contains noise in various forms, like emotions will be there, punctuations, and text. Suppose you take the data from Twitter. People make the post or tweets on their Twitter. Say someone says or made a post, I am happy, along with a smiley. So this is having some, exclamation marks over here. This is having some, smileys over here, emoticon. So these are nothing but a noise. When we talk about human language, there are different ways to say the same thing. For example, if I say, I'm going, I'm leaving, right? The meanings are same, but the different way to communicate. And this is only the problem, main problem we have to deal with, because machines will not understand the words. They need to numbers. So we need to convert this text to numbers in an efficient manner. That is your text pre-processing. For doing this, we use various tools like your BERT, spacing, and natural language tokenizer, NLTK. After extracting the data, it needs to be processed. And various processes that comes under your text pre-processing is tokenization, normalization, and noise removal. What happens now? Suppose you are doing the data collection. when you will choose secondary data source for your data collection, the data that you will collect over here, for a fact, you know that it won't be having or may not be having the data or the variables of your interest. And it will be containing a lot of missing values as well. It will be containing a lot of, uh, outliers. Typecasting will be needed. So all these things needs to be done, right? Even before you venture for your EDA. Another thing in the pre-processing is, based on the general outline, various steps under each components are removal of your HTML tags, removing extra white spaces, convert accented characters to ASCII characters, expand contractions, removal of special characters, lowercase letters, convert number words to numeric form, remove the numbers, remove stop words, and lemmatization. These are the various steps that come under each component. And another thing, as I was telling you, that the data that you collect from your secondary data source, it will be having a lot of missing values, or it will be a mix of various data types. So you do typecasting. Typecasting, you convert, say, integer to float, or vice versa. Handling duplicates, you will be having some duplicate values as well. You need to take care of that. Outliers will be there. So first you need to analyze. And for this we use box plot. You treat it using your trimming or winsorization, right? Various other things. Zero and near zero variance, discretization, missing values, NA. In our data set, you will be seeing NA, non-available missing. Dummy variable creation, transformation, standardization, string manipulation. These are the various data pre-processing techniques that we do. Okay. So besides working on these data pre-processing things, whatever we discussed till now, I'm going to take a use case. When we talk about capital market, in capital market, we deal with our, say, banking, stocks, cryptocurrency, right? Capital market. So today we are going to take a use case of cryptocurrency over here. And we are going to perform the EDA on this cryptocurrency dataset that we are having. I've used an open source data, which was easily available on the internet. And I have performed your EDA on that in my Jupyter notebook. So let us see. How do we perform the EDA and what inferences I made up by performing the EDA on this cryptocurrency dataset. Okay. So here, guys, I've imported my required libraries. I've imported NumPy SNP, I've imported Pandas SPD, I've imported OS, I've imported Glob, datetime, matplot, lib.picker. From that, I've imported scalar formatter, so on and so forth. I have imported my required libraries over there. Even before this, let me show you the dataset. So this is the dataset I have used. This dataset is containing around 37,082 rows and 10 columns. This dataset is having information of Aave, Binance, Coin, Bitcoin, Cardano, Chainlink, Cosmos, Crypto.com coin, Dogecoins, EOS, Ethereum, Lota, Litecoin, Monero, NEM, Solana, so on and so forth. So firstly, we started with importing libraries, as you can see over here. I've imported libraries. And what we observe is dataset having columns named as symbol, date, high, low, open, close, volume, market cap. All these are the various columns that we are having. When you observe over here, all these are the various columns that I am having. Now, when you are talking about the name, this is nothing but the name of the cryptocurrency. Symbol means symbol of your cryptocurrency. Date and time of the crypto when it is open, close, go high, go low, so on and so forth. When you talk about high, the highest value when crypto opens, this is what it is showing. Low is the lowest value when your crypto is opening. Open, value of the crypto at the time of market opening. Close is telling you the value of the crypto at the time of market closing. Volume is telling you the volume generated by your cryptocurrency. I have imported this data set. After importing this, when I got this inference, what I'm trying to do is, I am trying to find the top 5 cryptocurrencies based on the market capture. Based on this market capture, I am trying to find top 5 cryptocurrency. And for that, what I'm doing is, I am saying using your pandas to_date time, create from the data frame date, take the column date, and whatever values you are getting, store it into this new variable, and I'm plotting the plot over here. And when I am plotting it, I'm observing that based on the market capital, Bitcoin, Ethereum, USDT, BNB, and ADA are the top 5 cryptocurrencies in the market cap, by a market cap. This is a simple matplotlib graph that we are having. And this graph came after grouping by symbol on the market cap. Here, what we observe is, we can see the Bitcoin is the highest value according to the market capital, and Ethereum is 50% of it. And others are very less in comparison to it. And USDT is 3 times less than your Ethereum. Right? Now, we talked about first movement business decision. And in first movement business decision, what we do is we try to find out your mean, median, and mode. So here I am saying df.marketcap.mean. Take this market capital from the data frame df and calculate the mean. So when you calculate the mean, you have this value. When you calculate dot median, you get the middlemost value. When you calculate the mean, you get this. Then we talked about calculating your second moment. And in this, we do variance, standard deviation, and range. So what I'm doing over here is I'm installing your NumPy and I'm importing your stats. After that, I'm saying from the dataset df.market_cap, which is your column, calculating the variance. This is the variance value that I'm getting. I am also calculating your standard deviation and I'm calculating your variance and standard deviation for volume as well. Right. Now, after doing this, I calculated your range also. That is a part of your second moment business decision. And I'm saying the range is nothing but your maxima minus minimum. But maximum of what? Market capital, which is existing in your data frame DF. Minimum of what? Market capital, which is existing in your data frame DF. And when I say range, this is the range I'm getting. I'm also calculating your third moment, which is nothing but a skewness. I'm also calculating the skewness for two columns for market cap and volume. The same I'm doing for your kurtoses, market capital and volume. So I'm getting various skewness and kurtoses values over here. Now, I'm saying dx is equal to df.copy and it is showing me top four currency names. Means I've taken your top four currency names by single market cap, so on and so forth. Wherever you have, means I'm taking your symbol and market capital. Based on that, I'm saying give me the top four values. It is going to give me my whatever top four values it is. Then I'm also trying to find the top four currency names, except first, except two, except first two. So in this way, I'm getting your various values. I'm also trying to find your top four currencies. Here I'm trying to find your top four currency names. Here I'm trying to find your top four currencies. I'm also doing your figure plotting over here. And I'm drawing a plot. The plot of the title is closing prices of the top four cryptocurrencies. So what I'm doing over here is I'm trying to find the closing price of my top four cryptocurrencies. And when you observe, the closing price of your Bitcoin is the highest compared to BNB, Ethereum, and USDT. You can't even see BNB over here. So the highest closing price for your cryptocurrency was for your Bitcoin. Now, all this thing is fine. Clearly, we can see that Bitcoin is the highest, and compared to others, when we compare others with Bitcoin, we can't even imagine where they are standing. So what I did was currencies besides your Bitcoin, for obvious reasons, because it is very high. So here I'm taking the closing price of top four cryptocurrencies except Bitcoin. And these are the parameters I have given, using which I am plotting this particular plot. Figure size I have given as 2025. You can give whatever you want. plt.subplot 4, 1, 2. I have not used your Bitcoin over here. And these are the various titles and legends I am using. So here, if you observe in this plot, you can see that besides Bitcoin, Ethereum was also having a very high closing price. Right. If you observe over here, Bitcoin is the highest. But now, if you observe over here, besides Bitcoin, if we leave, Ethereum is also high. Then I'm also trying to visualize the closing price of top 4 cryptocurrencies except your Bitcoin and your Ethereum. Here I've taken the iteration as 3. So here you can observe for your BNB and XRP, the closing price. Trying to find the closing price of top 4 cryptocurrencies except BTC, Ethereum, and USDT. So here, if you see BNB, that is having a closing price of say somewhat 680 or 690. XRP is again lying at the lowest. Now, for all the values in Bitcoin, Ethereum, top 5 cryptocurrencies, options I'm choosing as I. I'm saying from the data frame take the symbols is in is equal to options, and I'm creating a candlestick chart over here. Initialize the various parameters. And this is the candlestick chart I'm making, which is showing me the moving average versus closing average price for Bitcoin. So if you observe this blue line that you are seeing, this is nothing but your closing price. And this is a moving average 1. And this is a moving average 2. On an average, what is the movement of this cryptocurrency compared to your closing price? I'm also trying to find the inferences for the Ethereum, USDT, BNB, and ADM. Reason behind these were the top 5 performing cryptocurrencies compared to all other cryptocurrencies that we were having in our data set. Now I'm also trying to import my plotly.express as px, and I'm initializing some parameters over here. Dictionary count is equal to 6, count is equal to 1, 6, 7. I'm taking various variables over here. And when I say area.show, so the point which I'm trying to make over here is, or the point that you are seeing over here is, what we observed is in 2021, the value of the Bitcoin was at an all-time high. In 2021, the value of your Bitcoin was all-time high. And nearly $60,000, which is almost 15 times more than the second highest cryptocurrency. That is your Bitcoin, Ethereum. What is the highest? Maybe 4,200. And we are having 60,000 for our Bitcoin. Among these top cryptocurrencies, the growth of your Bitcoin, Ethereum, and USDT over the last 5 years was beneficial among the investors. If you observe for your Ethereum, sorry, this is for your, Ethereum. Let's discuss about Ethereum. So what you are observing is that from the past 5 years, from 2017, 18, 19, 20, 21, you are seeing a continuous growth for your Ethereum. And the same goes for other cryptocurrencies as well. Remember, we are dealing with top 5. And in top 5, we are having Bitcoin, we are having Ethereum, we are having BNB, we are having ADA, we are having fuel. So if you observe over here, even your BNB from the last 4 years, you can say 18, 19, 20, 21, and so on, you are seeing a consistent growth, right? And that is why BNB. Okay. Just a moment, guys. I'm trying to figure out something. Okay. So this is how I perform your EDA on a given data set. So what all things we learned? We learned today that EDA is an approach to analyze the data using visual techniques. It is used to discover the trends, patterns, or to check your assumptions with the help of the statistical summary and graphical representation. And we are trying to, perform various statistical analysis. And from these analysis, we try to find out about what, graphical, using the graphical representation, we try to visualize it. So in short, if I were to say, in statistics, EDA is an approach of analyzing the data sets. It is an approach of analyzing the data sets to summarize their main characteristics, often using the statistical graphics and other data visualization methods. A statistical model can be used or not, but primarily IDA is for seeing what the data can tell us beyond the formal modeling and thereby contrast traditional hypothesis testing. When you talk about EDA, it was promoted by John Turkey. Right? So it is usually to encourage the statisticians to explore the data and possibly formulate hypotheses that could lead to new data collection and experiments. EDA, when we talk about, guys, it is very different from IDA. IDA is initial data analysis, which focuses more narrowly on checking assumptions required for model fitting and hypothesis testing, and handling missing values or making transformations on the variables as needed. When you talk about EDA encompasses your ideas. Right? We're talking about the techniques and tools that we use. We can use your box plot. We can use your histogram. We can use your multivariate chart, as I told you. We can use your run chart or heat map, bar chart, so on and so forth. When you talk about the dimensionality reduction, we use your PCA component. PCA. We talk about SVDs there, so on and so forth. Right? So this was all about your EDA, guys. And this is how we perform your EDA on your given data. Talking about cryptocurrency that we saw, which is again an example of your, capital market analysis that we were discussing about. And what we did over here, we basically used your EDA to see what data can reveal beyond the formal modeling or hypothesis testing. We saw that how is the movement of your each cryptocurrency or top 5 cryptocurrencies for the last 5 years. Are they continuously moving up or they continuously moving down is what we saw over there. And by using the EDA, we got the better understanding of your data set variables and the relationship between them. We can also use it, or it can also help your EDA to determine if the statistical techniques that you are considering for data analysis are appropriate. And the main purpose of your EDA is nothing but to help look at the data before making any assumptions. It can help identify obvious errors as well as better understand patterns in the data, detect your outliers or anomalous events, as well as it also helps us to find the interesting relationship among the variables. As a data scientist, we use EDA to ensure the results that they produce are valid and applicable to any desired business outcomes and goals. EDA can help the stakeholders by confirming they are asking the right questions. EDA can help answer questions about a standard deviation, categorical variables, and confidence intervals. Once your EDA is done and insights are drawn, its features can then be used for more sophisticated data analysis of your model, including your machine learning. That is. In Python, when we talk about Python, when we use for our EDA, Python is nothing but an interpreted object-oriented programming language with dynamic semantics. Its high level and built-in structure, data structure combined with dynamic typing and dynamic binding makes it very attractive for the rapid application development as well as for use as a scripting or glue language to connect existing components together. Python and EDA can be used together to identify missing values in a dataset, which is important so you can decide how to handle the missing values for your machine. So guys, this was all about our today's session. We did discuss about EDA. We did the hands-on. So wrapping up the session for today, guys. Thank you so much for joining. Tomorrow again, we'll be meeting and taking the things further from here. Again, it was a very pleasure taking this session for you guys. It has been a wonderful experience. And thank you so much for joining. We'll be seeing you people again. Thank you so much.